Hello student, my name is Vikas Jha and I have completed my M.Tech from NIT Allahabad in manufacturing engineering, and after completing M.Tech I am teaching this manufacturing engineering from 2017, and I have taught around 20 batches in this 8 months, and today we'll discuss the importance of this manufacturing and we'll discuss the different topics that we have in manufacturing engineering. Now, before going into the topic, we'll talk about the manufacturing technology, what actually this subject is and what are the things that we will study in this subject. Before going into that each topics, we'll discuss the importance of this subject in GATE. Now, if you will see, its weightage in GATE, it's around 18 to 22 marks. If you will see this paper of 2018, its weightage was 22 marks in set 2, and in set 1 it was around 17 marks. So if you have a good grip on this manufacturing engineering, if you have a good grip on mathematics and engineering aptitude, you can easily score around 50 marks. So it's basically it is 50% of your total marks, that is 100. So to get the good rank and good marks in GATE, you will have to know the manufacturing engineering. You will have to know. Without manufacturing, you cannot get a good rank. You cannot even get more than 50 marks. I can guarantee that. So, this subject is very important and this subject is very easy, if you will see. Easy means, if you know the formula, if you know the basic concepts, you will be able to solve each and every questions. Each and every question means, if you will see the thermodynamics, if you will see the theory of machine, there you will have to visualize. Visualize the things. Without visualizing, you will not be able to solve any question. But in manufacturing, it's all about the basic concepts and formula. You will see when I will discuss the different topics in manufacturing engineering. Right. So, why I'm telling you all this? Because it's very easy. Because you can easily get that 18 to 20 marks from this manufacturing engineering. So, in this manufacturing engineering, we'll discuss the different topics like casting process, we'll discuss the metal forming, we'll discuss the machining process, we'll discuss the welding process, we'll discuss metrology, and then SIM, that is computer integrated manufacturing. That is, in that topic we'll discuss about that CNC machine and how to do the programmings, right? Now, before going into each and every topics like about the castings, metal forming, then welding, we'll tell you which book you have to refer for this subject, right? So basically, you can refer the manufacturing science by A.K. Malik and Amitabh Ghosh. Then you can refer manufacturing technology, volume 1 and volume 2 by P.N. Rao. And then we have the manufacturing science by Kalpak Jain. And you can also refer the manufacturing, fundamental of modern manufacturing by M.P. Gruber. So these are the different books that we have. So manufacturing science by A.K. Malik and Amitabh Ghosh. Then you can refer the manufacturing technology by P.N. Rao, that is your volume 1 and volume 2. Now, you can also refer the fundamental of manufacturing engineering by M.P. Gruber. And so if you will ask me which one is the best for GATE, I will tell you this: manufacturing science by A.K. Malik and Amitabh Ghosh. This one is the best book for GATE. Now, if you are studying this manufacturing science by A.K. Malik and Amitabh Ghosh, and if you have some doubt, you can refer manufacturing technology by P.N. Rao. This one is also a good book for that manufacturing engineering. Then we have this fundamental of manufacturing engineering by M.P. Gruber. Now you can refer this book for this SIM and that NC and CNC machine. So in Manufacturing Science by A.K. Malik and Amitabh Ghosh and Manufacturing Technology by P.N. Rao, Volume 1 and Volume 2, you will not get this SIM and NC. So for that SIM and NC, you can refer this MP Gruber. So now, what I was talking is like, if you have a good grade in manufacturing engineering, and if you have good grade on mathematics, engineering mathematics, and aptitude, you can easily get 50 marks. Now, if you are an engineer, so obviously you will be good at engineering mathematics and aptitude. And if you have the basic concept and if you know the formula, you can easily get it into that 22 marks. So it's easy to get that 50% marks in GATE if you know these three subjects. These three, that is manufacturing engineering, engineering mathematics and aptitude. Now this subject manufacturing, no need to visualize the things. If you know the basic concepts, basic principle of all the manufacturing processes, and if you know how to find out the different forces, how to calculate that allowances and different forces in rolling, extrusion, in different manufacturing process, you will be able to solve the question in GATE. Now in manufacturing engineering, since in your engineering, the basic perception about this subject is a theoretical subject. But I'm telling you, this manufacturing in GATE is completely numerical. All the question means out of that 18 marks, 12 marks question will be numerical. And the remaining 1-2 question will be theoretical. So theoretical means we have number of manufacturing process. In that manufacturing process, we will have some defects. Right, in casting, so obviously there are number of defects in casting. In metal forming, again there are number of defects in metal forming process. In machining, we have something. So from there you will get some theoretical question and some basic principle of different manufacturing process. From there you will get some theoretical question. And the remaining that 12 to that 15 marks will be completely numericals. So you will get that numerical question from that. So if you know the formula, you know the basic concept, just take that given data and put into that formula and just calculate the result. That is all about that manufacturing engineering. Now, before starting this subject, we'll write down the different topics that we have in manufacturing and what are the things that we are going to discuss in this subject. So, we'll start our discussion with the casting process. So first we'll discuss the casting process, then we'll discuss the welding. After welding, we'll discuss metal forming process. After metal forming, we'll discuss the machining process that we have, and after machining, we'll discuss the metrology. And then we'll discuss the SIM, or is a computer integrated manufacturing. So these are the different topics that we have in manufacturing, and we'll talk about it. Like in casting process. So it is one of the oldest manufacturing process that we have. So basically what we have to do is, suppose if we have anything like this one. Now to make this one we require some raw materials. Okay, we require raw materials. Now that raw material is of no use. Okay, that raw material is of no use. So what we will do is, we'll convert that raw material which is of no use into some product, into this product. Okay, so basically what we are doing is, we are adding value to the raw materials. Okay, we are adding value to the raw material. By adding value to the raw material, we are converting that raw material into a final product. So the raw material which is of no use because of its irregular shape, indefinite size, because of its poor surface finish. So we are adding value to that raw materials and we are converting it into a final product. Suppose this one. Now this product obviously have the definite shape and definite size. It has the better surface finish and this can be used to fulfill some functional requirement. So this is basically the definition of manufacturing engineering. Okay, manufacturing engineering. So how will we define if we have a raw materials? Okay, it's a process of converting the raw material which is of no use because of its irregular shape, indefinite size, poor surface finish, can be converted into a product by some processes. Okay, into a product which will have the better surface finish and better dimensional accuracy and can be used to fulfill some functional requirement. Okay, so in casting process what we will do is, suppose we have the raw material. Okay, we'll melt that raw material. Once we melt it, we'll pour that molten metal into the mold cavity. So that mold cavity is to be made by using some pattern. We'll discuss about that. So that molten metal is to be poured into that mold cavity and then it is allowed to solidify. Now after solidification, what we will do is, we will take out the product by breaking the or separating the mold. So in this way we can convert our raw material into a final product which will have some functional requirement. Now in welding, what basically we do is, we join two components. Okay, so it's a joining process. Okay, so to make a product, what we will do is, suppose if we have a product which consists of the number of parts, so we'll weld all the different parts to make that final product. Okay, in order to get some that functional requirement or some properties. In metal forming process, what we will do is, suppose we have the raw material. In that raw material, what we will do is, we'll apply some force by using some die or by using some roller or by keeping that into a chamber, and then we'll apply the force by using some ram. So basically this metal forming is a plastic deformation process. We are deforming the raw material above the yield point. So then only obviously there will be plastic deformation, so that once you release the load, it will not get or it will not come to that original state, original size. Okay, so metal forming process is a plastic deformation process. We are deforming the raw material plastically in order to get the required shape. Now in machining process, basically this is a finishing process. Okay, basically finishing process means, suppose if you are making the product by using that casting process or by using metal forming process, you will not get that much, the surface finish. Now to get the required, suppose if you have to make a cylinder of say 25 centimeter diameter. Now obviously that cylinder requires very good surface finish, and that we are not getting with that casting process or by using some metal forming process. But for that cylinder, we'll have to make the good surface finish. So what we will do is, we will remove that extra layer of material from that cylinder. We'll remove the layer of material from the component in order to get the required surface finish. How will we remove that material from the component? By using some kind of tool. Now obviously that tool and the product that should have the good surface finish, it should have some relative motion, then only we can remove the materials. Obviously to remove the material from the workpiece, your tool material, the hardness of the tool material should be greater than the hardness of your raw material or the component. Then only you will be able to remove that material. So in that machining, we'll discuss about the different forces and the mechanism of that chip formation, mechanism of that material removal from the workpiece. Then metrology is basically that science of measurement. So in this metrology, we'll discuss about, how to give that limits and tolerances to the shaft and the hole. Now, because we know it's very difficult to make the component exact to its dimension. Suppose if we have to make a cylinder of say 24.66 mm diameter. Now it's very difficult to make that cylinder whose diameter should be say 24.66 because of some machine error or because of some human error. So it's very difficult to make that exact dimension. So what we do is we give some that limits. Limits means the maximum and minimum permissible dimension to that cylinder. So that by making the component by using some of the process, if your dimension lies within that limits, then we can say that your component is acceptable. Otherwise, we have to reject that. So in that metrology, we'll discuss about how to give that limits and tolerances, what are the different types of fits that we have, what are the different types of fits like clearance fit, transition fits and interference fit. Okay, how to find out that maximum clearance, minimum clearance. Okay, then we'll talk about how to do the inspection of that shaft and hole by using some different gauges like go and no go gauge. Okay, so we'll discuss about all these things in metrology. Now in SIM or in computer integrated manufacturing, we'll discuss about the NC machine, numerical control machine, and CNC machine, and then how to do that programming, how to write that program, and how to identify. Like we have some codes, right? G code and M code. Now again in that we'll discuss about the BLU, basic length unit. Okay. So these are the different topics that we have manufacturing. We'll discuss. Yeah.